Chapter 15, Quantum Translation, Section 15.8, Quantum Confinement. As the conjugated carbon chain of a polyene molecule increases, the HOMO-LUMO gap of the polyene becomes smaller. It's called redshift. This is because this value, n LUMO squared minus n HOMO squared, is roughly proportional to the number of carbon atoms. While on the bottom we have A squared. A squared is roughly proportional to the number of carbon atoms squared. Now let's look at this equation of HOMO-LUMO gap. It's n LUMO squared minus n HOMO squared multiplied by H squared over 8Ma squared. When the number of carbon atoms increases, this will increase, but also this A squared will increase. A squared increases faster than the difference between n LUMO squared and n HOMO squared. Assuming the average carbon-carbon bond distance is 1.4 angstroms, then the length of the 1D box is roughly n-1 times 1.4 angstroms. So if you have 6 carbon atoms, there are 5 bonds. If you have 8 carbon atoms, there are 7 bonds. So that's why n is the number of carbon atoms and also the number of pi electrons. Therefore, n HOMO is n over 2, and LUMO is n over 2 plus 1. This is because in each MO we have 2 electrons. Therefore, if we have n electrons, they occupy 1/2 of n MOs. Now let's look at the expression of the HOMO-LUMO gap. This is the quantum number for LUMO. This is the quantum number for HOMO. We take the squares of these two numbers and then take a difference. Here we have H squared over 8Ma squared. A is the box length. In this case, A is n-1 times 1.4 angstroms. Again, with n atoms, well, there are n-1 carbon-carbon bonds. Now, the HOMO-LUMO gap is proportional to n plus 1 over n-1 squared. We can see n-1 squared over here. Where does this come from, n plus 1? Actually, if you just evaluate this n over 2 plus 1 squared minus n over 2 squared, well, the difference is n plus 1. And therefore, the HOMO-LUMO gap is proportional to n plus 1 over n-1 squared. As n increases, well, both the numerator and denominator increase, but the denominator increases faster, and we have a smaller energy gap when we have more carbon atoms. It's called redshift. When n is much greater than 1, n plus 1 is close to n, and minus 1 is close to n. Now the HOMO-LUMO gap is proportional to the reciprocal of n, or the reciprocal of the number of carbon atoms. So now it's really clear that when we have a longer polyene molecule, we will observe a smaller HOMO-LUMO gap. The HOMO-LUMO gap is approximately inversely proportional to the chain length, or to the number of carbon atoms. In general, when a particle is confined, its energy is quantized. When the particle is confined in a smaller space, its energy spacing are larger. It's called blue shift. But when the particle is confined in a larger space, the energy spacings are smaller, and that's called red shift. When a particle is not confined at all, its energy spacings become infinitesimal or zero. For example, the energy of a free particle is continuous with a zero energy spacing, only because the free particle is not confined at all. And this figure depicts the redshift of the HOMO-LUMO gap as the size of some nanoparticles increases, and this phenomenon is called quantum confinement. It's often used to fine-tune the optical properties of nanoparticles. Mostly it's just the color of those nanoparticles. When we have a smaller particle, usually we have a larger energy spacing. When we have a larger particle, usually we have a smaller energy spacing. Also, we can see E sub g stands for the energy of the gap. Alright.